Next question is that we have been given an integer array. Okay, now just look at the question carefully. Okay, the question says that all elements appear thrice. Thrice means 3 times. Okay, just one element comes once. Find that. So there is an array in which every element is going to come thrice. There is just one element which is going to come once, and you have to detect that element which has come once. Let us take a quick example. Let's say my input contains something like 1 2 4 3 3 2 2 3 1 1. Can somebody tell me what will be the answer for this case? 4, right? Very good. Now you think the approach on your own, okay? And I would highly recommend pen and paper. Take pen and paper, do some work, do some pattern finding, and then see if you can come up with something. So guys, if I simply sort it, can I do it? I think yes. If I just sort it, I've told it before, what does a sorting do? Sorting ensures that, and what Nishant says make a lot of sense. Everyone can read that. By the way, if I sort it, then the equal values numbers are clustered together. Yeah, even Ankur makes sense. So if you sort, the same value numbers are clustered together. Yes, no? If you sort, this is the sorted thing that you will get. Right, wrong, can you say that? Right? And now I think it is very easy to detect. No need of map or anything, nothing. You simply need to check, let's say you start from so you want first such number such that towards its left there is a different number. Okay, so let's say you have a 1 over here. Okay, then as long as you get 1, you keep moving. And let's say there was just one occurrence of 1, this would have been your answer. And now once again you are here, if there was just 1 2 and there were no 2's in the right side, this would have been your answer. Otherwise you keep moving, and so on and on. In one traverser only, after sorting, you can detect this 4. So that is one way. It would have taken you how much time? What would have been the time complexity of this approach? Quick, can somebody tell that? And log n. Yes. Can I do it in order n time if I use hash map? The answer is yes. You can simply use a map to store the frequency of all the numbers, right? And then you can iterate on the map, or you can even iterate on the numbers, and the first such number whose frequency is not equal to 3, that would be your answer. Is that approach clear? Yeah, and there is one binary search based approach also, so that would also work, okay, after sorting, obviously. First of all, if this question gets asked to you in the interview, and let's say I'm the one being interviewed, and let's say I don't have a lot of confidence on bit manipulation, say for example, then at least I'll speak these approaches very, very clearly. And if the interviewer makes me code them, I'll code them without any flaw. Okay, that still raises your chance of getting a, just chance, okay, some interviewers might still reject, but there is a chance that you spoke of some of the approaches. So you have to be clear with the basic and intuitive approaches for sure. Okay, everything else is, cherry on top of that, right? So yeah, let's add cherry here. So guys, let me question you one thing. Let's talk about any number like 2. Okay, let's say there is 2. The binary representation of 2 is like this, 1 0, and then everything else is 0 here. Now answer me one thing. If this is an array of integers, what can be the maximum number of bits present in any number? Is 32 a safe value? Because because I said it is an integer, but let's say if it can be long integer, then what can be the maximum number of bits? 64 bits, right? Very good, 64 bits. So let's say I'm just tracking all those 64 bits by something. So this is a tracker of bit position 0, this is a tracker of bit position 1, this is a tracker of bit position 61, bit position 62, bit position 63. Will there be a bit position 64? Why? Because indexing is from 0. and this is 2 raised to power 63, right? So I hope you understand that. Cool. Now one thing that I want to ask is, let's say there is this 2 whose binary representation is like this. So first of all, let me ask you, how many of you were thinking about using XOR over here? Yeah, when I also saw this question for the first time, my intention was to do that first. But did that help you? Did that help you? No, it did not help. Can you tell me what did you get when you took XOR of this entire thing? XOR of all the unique numbers. Because if let's say this is 1, then 3 times 1 XOR will be equal to 1. 3 times 2 XOR will be equal to 2. 3 times 3 XOR will be equal to 3. And for just 4 it will be 4. So it will be it will simply be the XOR of unique numbers. Because if you take XOR of everything, it will be the XOR of all the unique numbers. And then what will you do with that? You can't do anything further with that. If I track that, how many numbers are having at this bit position, which is how many numbers at this bit position are having a value of 1? If I want to track that, I simply want to track that. I repeat it again. I want to track it, that how many numbers are having at B1 bit 1. Let us just forget this 4 for a while. If you forget this 4 for a while, then can you tell me that what will be the count over here? How many numbers will be having first bit as 1? Just iterate on the array and tell me. 6. Very good. What is the representation of 1? This is 0, 0, 1. 2, it is 0, 1, 0. 3, it is 0, 1, 1. So this 1 at bit 1 it has 0, so it will not contribute. This 2 at bit 1 it has 1, but this 2 has come 3 times, so plus 3 will happen for 2, right? Will this plus 3 happen again for some other number? Will it happen again? Yes, it will happen for 3 also, because even for this 3 which has come for 3 times, bit 1 is 1, so plus 3 will happen again. So what do you see? Do you see this thing that the number of this particular count that I am talking about, the number of elements which have bit 1 as 1, that number will be a multiple of 3. It will definitely be a multiple of 3, and it would be true for all the bits. If let's say some bit is 0, then even 0 is a multiple of 3, right? Now if a number has come just one time, what will happen? So the representation of this is something like this. So what will it do? It will bring a plus 1 over here. It might bring plus 1 at certain other places also. So it will basically bring plus 1 at those bits which are 1 bits in the binary representation of this number. And now there will be 2 kind of categories of these counts. First category will be 3 into x, and second category will be 3 into x plus 1 because of this number. Is that clear to all? So now the job becomes very easy. Now the job just becomes that I have to iterate across these. iterate across these bits, and while I am iterating across these bits, if I see that the value at a particular position is 3x plus 1, if the value at a particular position is 3x plus 1, then that is the bit which is on in this particular number. So I'll add the contribution of that bit to generate this number. So I'll do answer plus equals to 2 raised to power I. If that position was I. Again at some other position I see that the value is 3x plus 1, then again I will do answer plus equals to 2 raised to power j, and so on and on. Okay, then can you tell me the time complexity of this? So see how I can easily implement it. So implement it in a bitwise fashion. So guys, I'll tell you one thing, in the beginning you might feel a bit uncomfortable in writing the code using bitwise operators, but that does not mean you will leave it. You should definitely implement it, because those are faster and those are expected in interviews. Okay, should we take an array for counting 1? Yes, you can take that. Okay, you can take that, but that might not be very necessary. This is what you should understand. Okay, let me do one thing. Let me just try to implement it. So what I am basically going to do, I do not know what is the maximum number, that is what is the maximum number of bits in any number. So I'll assume every number to be a 64-bit number. Doesn't matter if it is as small as 1. I'll assume all previous bits as 000 each. Okay, and then there is some other number like this, and then there is some other number. Okay, so what I'll do, so these are the numbers, these are the binary representations of the numbers given in the array. And then what I'll do, I'll iterate from, let's say, this particular bit. Okay, I'll start my iteration from this particular bit, and I'll just try to see that how many numbers are having 1 at this bit position. Just look at it very carefully. I'm trying to see that how many numbers in the array are having 1 at this bit position, which is B63. And then I'll check for B62, so on. Eventually I'll check for B0, right? So can I do that? How do I do that? If let's say I just have to perform the first step, I have to just perform the first step of checking that how many numbers are having 1 at B63. What can I do? So guys, can I start with a mask? Can I start with a bit mask where the 63rd bit is 1 and everything else is 0? Can I start with something like this and take AND of this with all the numbers and check what is the result of AND? So welcome to the bit manipulation. This is how bit manipulation code is written. This is how you think at the level of bits, and please start thinking. You will hurt yourself if you don't think in terms of bit. So the game that I am playing at the level of bits, But I am investigating some property at different bit positions, and when there is a particular bit property, then I make a particular decision. So instead of playing at the level of numbers, you play at their bits. This is the most important thing behind bit manipulation. Okay, so let us start our journey. So I want to start with this particular bit position, which is B63. So for that, what can I do? I'll want to start with a number by creating this particular mask. So for that, I would need long int, let's say mask equals to something. Can you tell me what should it be equal to initially if I want to start with this? What expression will come over here? Can you quickly write that expression in the chat? I want to create that number which has 1 at 63rd bit and everything else is 0. What do I write for that? Yes, very good. 1 left shifted by 63 units. Okay, so 1 left shifted by 63 units. Okay, now what will I do? I have to iterate over the bits one by one. So for first I'll perform the iteration across all the numbers for this bit position. So for, let's say, int I equals to 63, I greater than equals to 0, I minus, right? So this I denotes the bit position where my investigation is running. Okay, now one more thing that I would like to share is that this thing is not actually needed to be declared outside. You can do it inside also. That currently, if you want to create a mask where the bit position I is 1 and everything else is 0, you can do that here itself. Mask equals to 1 left shifted by I units. Now you have this thing ready. Now through this you can scan bit 63 of all the numbers. Okay, and for that you would want to run a loop across the array. So you would loop like for j equals to 0, j smaller than n, and j plus plus. Okay, what should I do now? Now using this mask, I'm trying to check whether this number has a 0 or 1 over here. So what is the line of code that will come over here? Yes, if aj and mask count plus plus. Does that make sense to everyone? Actually it should, because what is this number? This number is aj, and if I take AND of this with this mask, and if that AND is 0, that means the ith bit for that number is 0. So what will I do? that if I will see that the result of bitwise AND of this with the mask, if the result of this is non-zero, if the result of this is non-zero, what does it mean? It means that the bit position over there is 1, right? So over there is a 1. So I will have a count with me, and that count will now be incremented. So by the time this loop is over, I would have scanned 63rd bit of all the n numbers, and my count would contain that how many numbers are having bit 63 equal to 1. So after this time, my count would either be 3 into n or it would be 3 into n plus 1. Now what is the decision that I should take? Now if I see that count mod 3 is not equals to 0. If count mod 3 is not equals to 0, does it mean that 63rd bit must have been on in that number which comes for just one time? So this 63rd bit would contribute to the making of that number. So what will I do? That number can be initialized as 0, and then I will do num. If this condition is true, I will do num plus equals to that. What should I do? Who will tell me that? Num plus equals to how much? Mask. Very good. No need of doing 2 raised to power I, because 2 raised to power I is already stored in the mask. So doesn't it look like a very simple piece of code? Very few lines are there, and bit operators are used in a very good way to achieve this task. So how many of you were thinking about creating an array for achieving this task using the algorithm that I had described before? You might have been thinking like that, right? But did I need any extra space when I took this path? So this kind of optimization is generally very possible when you use bit operators, and this code will be much faster than the other code where you do not use bit operators, right? Cool. Now take a look and tell me the time complexity. How many times outer for loop will run? It will run for 64 times. And how many times inner loop will run for every outer iteration? N times. So the total time complexity will be order of 64 into n. If the question would have explicitly stated this to you, that all the integers are 32-bit integers, in that case, what change you would have done in the code? Your I in that case would have started from 31, right? That is the only change. Okay. So the outer for loop depends upon the maximum number of bits that a number can have. Okay. If the question would have said something like this, that every number comes one time, every number comes, let's say, 5 times, and there is just one number that comes one time. In that case, you would have checked division by 5, because in that case, this count would either have been 5 into n or it would have been 5 into n plus 1. Okay, if the question would have said that, hey, every number comes 4 times, just one number comes one time, in that case, what would you have done? In that case, you would simply have taken XOR. XOR would have worked.